시작할까요? Hi everyone. 오늘 세 번째 시간입니다. 지금 현재 오스트리아에서 유로스킬이 열리고 있는데 친구들이 다 유로스킬 그 오스트리아에 다 가 있어요. 그래서 아마 오늘 접속자들이 별로 없을 것 같습니다.
Hello, so this is the third session of the welding. I believe that because of the ongoing Euroskills at the moment, most of you will be in Austria, so I expect that there will not be many participants today.
아마 경기 중인 우리 선수들이나 우리 그 심사위원들은 다 주무시고 있을 것 같아요. 한 7시간 정도 차이가 나는데 친구들이 어제 그 경기 내용을 사진으로 보내왔어요.
So I expect that most of the referees and experts might be sleeping at the moment because I believe that it's 7 or 8 o'clock in the morning in Austria. But some of the experts have sent me the pictures of Euroskills.
경기가 지금 한 3일째 정도 진행 중에 있고
So the Euroskills is on the third day.
지금 우리가 앞전 시간에 배웠던 파이프하고 플레이트 시험편들이 보이네요.
These are the pipe and plate test plates.
그리고 오늘 수업 시간에 할 프레셔 베셜 이 도면인데 유로스킬에 지금 현재 하고 있는 도면입니다.
And this is the Euroskill diagram for the pressure vessel.
도면에 보시면 여기 재료 목록이 나와 있고 그 다음에 여기에 지금 삼각도법으로 그려져 있네요. 도면이 그려져 있네요.
Now you can see the diagram in the left, and on the right you will see the materials.
모형을 이렇게 가접해 가지고 이렇게 보여주기 위해서 만들어놨네요.
And this is the tack welded pressure vessel.
월드 스킬보다 유로 스킬이 조금 수준이 낮기는 하지만 그래도 굉장히 수준 높은 대회라고 생각을 합니다.
In most of the cases, Euroskills require much lower level compared to the World Skills. However, Euroskills is still a very good competition.
이건 이제 다음 시간에 우리가 10월 15일 날 할 스테인리스 프로젝트하고 알루미늄 프로젝트예요.
And this is the stainless and aluminum project that we will be covering on the 15th of October.
이게 누가 출제했는지는 모르지만 굉장히 굉장히 어렵습니다. 디피컬트하네요.
You can see that it's pretty difficult and tricky.
플레이트 16T하고 10T하고 두 자세가 나왔고
And the two postures of 16T and 10T were revealed.
잠깐 유로스킬에 대해서 좀 알아보면 유로스킬은 그 2차 세계대전이 끝난 후 1948년쯤 젊은 청년들이 어디 갈 곳도 없고 목표도 없는 친구들을 위해서 기능대회를 만들었다라고 해요. 유럽에서 몇 개 국가가 출전을 해서 그게 시작이 돼서 그게 월드 스킬스로 변했다라고 합니다.
So the World Skills basically originated from the Euroskills that was implemented initially in 1948. That was after World War II, and most of the young people were in chaos and hopeless at the fact that they experienced the war.
그러니까 이제 젊은 청년들한테 꿈을 주고 희망을 주고 기능을 익혀서 사회에 환원할 수 있는 그런 기회를 주기 위해서 스페인 마드리드에서부터 시작을 했다라고 해요.
To facilitate the young experts to grow, Euroskills was first adopted. The Euroskill was first adopted in Madrid, Spain.
유로 스킬이 있었기 때문에 지금 월드 스킬이 있는 거겠죠.
Thanks to Euroskills, we have World Skills now.
유로스킬의 이제 뭐 역사라든지 조금 잠깐 알아봤고 우리 월드 스킬에 나왔던 이제 오늘 수업 시간에 배울 건데 프레셔 베셜 제품들을 제가 좀 찍어 놓은 걸 가져와 봤어요. 한번 보시고 영상 보도록 하시겠습니다.
So that was the brief introduction of the history of World Skills and Euroskills. Today, initially we will take a look at the pressure vessel project that I took pictures of.
이 사진이 아마 2015년도에 아마 나왔던 도면인가 13년도인가 언제적 도면인지는 모르겠습니다.
Preparation of base material weld
I believe
joints.
that this diagram is from
Prior to checking the
either
structure of
2015
pressure
or
vessel,
2013.
review the provided drawing.
잠깐만요.
One moment, please.
Two drawings, one for material list and another
자, 지금 수압 시험까지 한 제품들이에요. 쭉 한번 보실게요.
So these vessels went through hydro pressure test.
이게 이제 압력 용기를 찍었는데 가장 잘한 거 위주로 찍어놨어요.
These are the finest examples and practices.
보시면 프락스 용접, 그 다음에 GMAW, 프락스 뭐 이렇게 가지가지 들어가 있죠. 여러 가지가.
You can see that several methods of welding was adopted in this project, such as GMEW and Flex.
오늘 이 시간이 지나면 이 방송을 보시는 분들은 다 이 정도 수준까지 올라와야 됩니다.
Most of you watching this video are required to weld this well, as you can see in the picture.
여기 15번 선수 거네요. 여기 15라고 적혀 있네요.
Oh, so I believe that this is from the competitor number 15.
부분적으로 이렇게 사진을 찍어 놓으면 자세하게 관찰할 수가 있어요.
When you take a partial picture like this, you can see the beads much thoroughly.
여기 보시면 비드하고 만나는 부분, 비드 시점을 잘 덮었죠. 부드럽게, 스무스하게.
You can also see that the start point was covered by the beads very properly.
이 부분은 이제 우리가 가접이 끝나고 난 다음에 속비드, 필패스 싸놓은 부분만 지금 찍어봤어요.
And this is right after the fill pass is done.
앞전에 제가 이제 우리 플레이트 쿠폰 수업을 할 때 생명선이라고 제가 한 적이 있어요.
In the second session, when we discussed plate coupon, I referred to a line called the lifeline.
이 프레셔 베셜에서도 이 생명선을 지켜줘야 돼요. 이 선.
Please keep in mind that this line you're seeing on the cursor is also called the lifeline, and you must keep the beads within the lifeline.
이런 선들을 지켜줘야지 나중에 캡에서 쏠 때 비드를 반듯하게 작업할 수 있습니다.
Make sure that you have an even line so that after you are done with cap pass, the beads will be more beautiful, basically.
필패스가 이 모서리 엣지 부분을 절대 넘어서지 않았죠. 다 보시면.
Again, you can see that the fill pass has not exceeded the point, the lifeline.
지금 나오는 도면은 굉장히 좀 어려운 도면이에요.
This diagram you see now is one of the trickiest.
우리 코리아 전국 기능대에서 나왔던 제품들입니다.
These are the diagrams from Korean games.
이것은 이제 캐페이스까지 작업이 다 끝난 용기.
This is the vessel right after every welding is done, including the cap pass.
굉장히 뷰티풀하죠.
You can see that it's pretty beautiful.
아름답습니다.
Magnificent.
이렇게 부분적으로 필패스 작업을 한 후에 이렇게 사진으로 남겨놓으면은 어디가 기준이 되는지 컨트롤 라인이 이렇게 선을 긋고 그 다음에 이 모서리 부분은 이 라인, 엣지 라인을 기준으로 하고 이런 것들을 정확히 알 수가 있어요.
If you take pictures from time to time when you're working on the fill pass, you can understand the control. You can understand where to address the control line.
파이프 용접인데 이게 GMAW, TIG 용접, GTAW, 그 다음에 여기가 아크 용접, SMAW네요.
So this is basically pipe welding. You can see SMAW, GTAW, TIG, and GMAW.
일단은 파이프 용접은 잘 해놓으면 굉장히 부드럽게 보여요. 곡이 있기 때문에. 그런데 못 해놓으면은 굉장히 보기 싫어요.
When it comes to pipe welding, the skill depends a lot. I mean, the appearance of the weldment depends a lot on the skills, because if you do it properly, you can, as you can see in the picture, it'll be beautiful. If you don't do it well, then you will not have a good result.
파이프 용접의 난이도가 좀 높죠.
Pipe welding is one of the trickiest welding.
이것도 유로스킬에 아마 나왔던 제품들인 것 같고.
I believe that this is also from the Euroskills.
가접해 놓은 상태.
The tack welding is done.
그러니까 이번에 이제 영상을 보시면 아시겠지만 맨 처음에 재료를 받고 재료 목록을 확인하고 재료 치수 확인하고
As you could probably see, as you will be able to see in the video, after you receive all the materials, make sure that all of the materials are in correct order, correct form, and correct dimensions.
도면 독도도 해야 되고 도면 이해를 해야 되겠죠.
You will also be required to understand the diagram.
그러고 나면 이제 도면을 보고 이렇게 가접을 합니다. 태크 웰딩을 이렇게 하고.
After understanding the diagram, you will tack weld.
이래놓고 이제 스탬프 심사위원들한테 스탬프를 받아야 돼요. 안쪽에 내부에 용접한 부위는 있는지 없는지 검사를 받아야 됩니다. 꼭.
After that, the experts will go through inspection of the vessels.
이제 검사가 끝나고 나면 작업을 들어가는데 이렇게 필패스 먼저 작업을 깔끔하게 해야 되겠죠.
After you have after your vessel is accepted by the experts, you will commence field pass.
그러고 나면 이제 캡에서 쏘기 전에 이렇게 지금 라인을 그어놨죠. 이렇게 이게 기준선이다, 컨트롤 라인이다. 여기도 라인을 그어놨고 비드 끝 부분에 맞추기 위해서 이 파이프도 지금 라인이 보입니다. 여기 맞대기 라인도 보이고.
Prior to working on the cap pass, you will be able to see control line in all of the field pass.
이렇게 필패스를 작업을 했습니다.
That's how we worked on the field pass.
그 다음에 이제 표면 캡패스 작업을 마무리를 합니다.
Now the pictures you see now are how we worked on the cap pass.
자, 이런 걸 이제 다 해서 우리가 영상으로 제작해 봤어요.
So the video includes all of the details that I have mentioned.
그런데 이제 영상을 찍기 전에 도면이 공개가 되기 전이었어요. 영상 찍을 때. 그래서 지금 지금 찍은 것은 2019년도 독일 카잔이었나? 러시아 카잔 대회 때 용기 가지고 프레셔 베셔 가지고 지금 제품을 만들었습니다.
Please keep in mind that we took the video before the 2022 game projects were revealed. So the pressure vessel you're seeing now bases on 2019 Kazan game test project.
그러면 영상 보기 전에 일단은 2022년도 상하에 대해 도면을 먼저 한번 보고 영상을 들어가는 게 좋을 것 같아요.
Before we watch the video, let's take a look at 2022 revealed TP.
지금 이제 프레셔 베셜 공개 도면을 보면
You can see in the diagram that
도면이 여러 장이 있어요. 근데 이건 지금 제일 먼저 보셔야 될 게 이 재료 목록 도면이에요. 재료가 잘라져 있고 재료에 이름이 다 붙어 있죠.
there are several diagrams, but first and foremost, you will be required to look at the required material list. You can see that the dimension and the size and the shape of the materials are described in this diagram.
도면에 사이즈가 나와 있기도 한데 이쪽에 보면 재료 목록이 나와 있어요. 부위 한 피스 한 가지 들어간다는 소리죠. 그 다음에 이거 사이즈 이런 게 나와 있죠. 재질이라든지 파이프라든지 이런 것들이 정확하게 자세히 나와 있습니다.
You can clearly see the requirements of the materials in this diagram, such as when it's stated V, it means that there is only one material.
그래서 트레이닝 할 때는 이 재료 목록을 보고 재료 준비를 해 주셔야 돼요.
So when you are training, please refer to this diagram and make sure that you have all the materials in the correct form.
이제 그게 끝나고 나면 이 도면을 보셔야 되겠죠. 이
After-
도면
After you're done with that, please refer to this diagram.
이 도면을 보면 이제 여기 덮개는 몇 미리가 나와 있고 밑판은 뭐 몇 미리, 파이프는 어디가 붙는다 이렇게 치수가 정확히 나와 있습니다.
And you can see all of the proper dimensions, such as pipe goes here, the plate comes out where. You can see all the correct and precise dimensions in this diagram.
이걸 보고 이제 가접을 하시면 돼요.
This is the diagram that you will be referring to when you're working on the tack weld.
그리고 이제 가접이 다 끝난 후에 가접 검사를 받고 스탬프를 받고 난 다음에는 이 도면을 보셔야 돼요.
After the tack weld inspection is done, please refer to this diagram.
이 도면을 보시면 여기 111번은 SMAW, 135번 GMAW, 136 FCAW, 141은 GTAW라고 나와 있죠.
You can see on the top right hand side of the diagram that you can see the details in the chart.
이걸 보고 이제 이 도면 뭐 평면도, 정면도, 측면도를 보고 여기 141번 GTAW로 각장은 4, 공차는 플러스 2mm 마이너스 제로로 용접을 해라 이런 뜻이죠.
You can see the acceptance and the tolerance in the diagram as well, such as how to weld and what to weld and how long you should weld.
여기 보시면 이것은 이제 파이프 용접이 되는데 전둘레 용접을 V홈으로 141번 GTAW로 용접을 해라 이런 소리입니다.
You can see that in this part you must commence GTAW in V shape. That is, when you look at the coupons, you will see a horizontal V shape.
만약 이 도면을 잘못 보고 여기 뭐 141번으로 용접을 하라고 했는데 111번으로 했다 그러면 여기는 점수를 하나도 받을 수가 없어요. 그래서 굉장히 도면을 잘 봐야 되고 도면 독도에 대해서도 공부를 좀 하셔야 됩니다.
Yeah, you must keep in mind that the welding must be done precisely as the diagram demonstrates. Otherwise, you will not have any marks. So keep in mind that you must follow all the instructions precisely.
그리고 이 도면 밑에 이제 노트란이라고 이렇게 나와 있는데 이 부분도 정확히 다 읽고 이것을 다 수행해야 됩니다. 뭐 테크 길이는 15mm로 해라. 각 장은 10에서 플러스 2로 해라. 여기 있는 조건들을 지키지 않으면 점수를 높은 점수를 받을 수가 없어요.
And please also consider the conditions and requirements in the notes on the bottom left side of the diagram.
자, 여기 계신 분들은 이제 이 정도 수준은 다 뛰어넘었을 거라고 보고 그러고 나서 이제 제가 영상을 만들었어요. 영상을 이제 보면서 방금 제가 했던 말들도 머릿속으로 생각하면서 보시면 아마 이해가 굉장히 빠르리라고 생각을 합니다.
I believe that most of you already are familiar with the details that I have mentioned. So let's commence the video and watch the video, and you will realize that you can follow the instructions in the video.
자, 한번 볼게요.
Form for the welding process will be provided. Cross-check the material list drawing and given materials, and check if any missing parts or materials with incorrect size carefully. Measure the size of every single material with a steel ruler. While measuring the size of elements, confirm where they should be located on the pressure vessel. Confirm if the size of each joining parts to be assembled is the same. The actual size of parts could be different about 1 to 2 millimeters from the drawing. In this case, increase the gap as the amount of the difference or reduce the size by trimming with a grinder. After confirming the size, mark the assembly location on the pressure vessel where it belongs to. A paint marker might be used for marking on the material, but it is recommended to use chalk to remove it easily. Check the number of missing materials by marking the list symbol on the material drawing. After counting the number of parts, mark the details on the parts the location where it should be by cross-checking with the drawing, and whether removal of the oxide layer is required. Make sure to measure the size of pipe with vernier calipers. The thickness of pipes should be measured as well. It is not allowed to replace the parts once tack welding starts. Prior to tack welding, check the material carefully, and if there is any material with incorrect size, ask for new part. Especially for pipes, assemble the parts in advance and confirm the size of cover plate is correct. After verifying the material list, remove burrs completely, remaining on the edge of the material. Most of the material provided for the completion will be laser cut. Cutting face will be clear, but burr may be noted on the edge of the materials. If the residual burr is not removed, it may cause misalignment while tack welding. Fix the material with a horizontal vise and remove the burr on the side of the plate with a file. After removal of burr, bring the material and return to the welding booth. The workflow up to now is preparation scope and not consider as the task time duration. But pay attention carefully than any other process, since this is the process to check the materials whether materials have provided inaccurately. Tack welding for pressure vessel. Welding process used by welder. Recommended using FCAW process for fast working and better weldability. For tack welding, welding tools such as steel ruler, magnetic base, hammer, and square gauge are required. Check the material list drawing and prepare for tack welding. 3 base materials will be used for the side section. Adjust the misalignment of plates with a steel ruler and fix the plates with a magnetic base. Tack weld will be made after assembly of 2 plates, not 3 plates. When trying to make many tack welds for many parts at one time, it will cause misalignment. Make 1 spot tack welding and continue tack welding, checking the misalignment with a steel ruler. While tack welding, shrinkage occurs at the tack point. Remained shrinkage will cause misalignment or defects on the completed task. Flatten the shrinkage area with a hammer. Attach the 3rd plate to use for the side section at the tacked 2 plates. When the surface of the tacked plates is not even, there may be a misalignment when placing the 3rd plate together. Check the alignment with a steel ruler securely and fix plates with a magnetic base. For butt joint, put the plates on the table and adjust the misalignment with a magnetic base and make a tack weld. Tack weld a butt joint for the side section. After finishing tack welding, check the misalignment with a steel ruler. Check the plates whether it has any issues, since tack welding could cause shrinkage of the base materials. If required, flattening the plate with a hammer. Mark the location where oxide layers should be removed with a chalk. When FCAW and SMAW process is to be used, the oxide layer removal does not require. The oxide layer will be dissolved at the higher welding current. For the GMAW process, due to shallow penetration and sensitivity with a contaminant, the oxide layer shall be removed in advance. Assemble and make tacks in order of the left side section, front section, and right side section. After the flat plate's tack welding completed, tack welds a pad to be welded on the flat plate. First, refer to the drawing and mark the location of the pad. When dimensions for location of pad are incorrect, it's considered as incorrect work and a competitor will lose marks. In case of the pad, it should maintain 0 gap between the flat plates. If tack welds are produced incorrectly, the main welding will be very challenging. When corner joints have gaps or overlap, welding cannot be done with equal welding conditions because welding parameters need to be changed a little bit. Therefore, from the beginning of tack welding, plates shall put together tightly and maintain zero gap. The oxide layer needs to be removed since a pad shall be welded with the GMAW process according to the drawing. Remove the oxide layer around the marking line. This pre-work makes welding work easy. It seems tack welding takes a long time, but by doing this way, actual welding time will be reduced. Attach the pad to the flat plate with FCAW. Make tack welds at the location where the tack could be removed easily by the grinder. Since retack welding might be required if incorrect tacks made, the pad needs to be dismantled from the flat plate. Then, tack welding for pipes. Fix the pipes by using a V-groove block and magnetic base. Then, make tack welds. By using V-groove block, adjustment of misalignment will be easier since the position for pipes will be fixed. A V-groove block prevents the movement of pipes and adjust the misalignment with a magnetic base. Make 2 or 3 tacks for pipes. If too many tacks made on pipes, it will be hard to separate pipes when tacks made incorrectly. When performing tack welding, it is necessary to consider the failure of tack welding and reworks. Make tacks on pipe cover plates. To keep the gap between the pipe and cover plate, insert a steel ruler and weld tacks. The thickness of the steel ruler used by the welder is about 0.8 millimeters. After completion of tack welding from one side, remove the steel ruler and weld tack from the opposite side. Size of tack welds shall not bigger than requires weld size. If tack welds locates outside of main welding, final welding profile will be non-uniform since amount of weldment will be increased partially to cover tacks. When tack welding finishes from one side, remove a magnetic base and fit up the opposite side with tack welding. When pipe tack welding finishes, remove the oxide layer on the weld surface by grinding. After tack welding finishes on flat plates, make tack welds for the corner joints. Fit up the front and side plates vertically. Fix them with a magnetic base and align them at 90 degrees. Assemble each part and confirm the angle with a square gauge. If plates maintain even level while tack welding, the gap of the corner joint will be the uniform at bottom, middle, and top. Maintaining even level is the most critical point. If plates are not even, pre-assembly might not be possible. Once confirm the square angle, then make tack welds. Size of tack welds shall not bigger than the required weld size. When side section assembly is completed, install a cover plate and make tack welds. When tack welding pressure vessel, consider the following assembly sequence. Otherwise, it will be impossible to assemble or wide gap can be created when the next parts are assembled. When securing large material, use G-clamp to fix the plates. Even if plates have been fixed, double check if the square angle and correct alignment are maintained. Make tack welds on the cover plate. Assembly sequence for pressure vessel is not determined. However, it should be the way minimize the shrinkage distortion and residual stress. Therefore, it is recommended to assemble from left to right side from the plate. In general, weld butt joints having larger shrinkage first. Then, weld the fillet joints. After tack welding, check repeatedly to confirm the alignment. Assemble and tack weld the cover plate on pipes. Refer to the drawing and locate the pipe correctly. If pipes installed at an incorrect location, it will be considered as an incorrect work, and a competitor will lose the marks. Make tack welds for elbow-shaped pipe. Adjust the horizontal and vertical position of the plates and fix them with a magnetic base, then make tack welds. Make 2 tack welds on the location where tacks could be removed easily by grinding. After tack welding, confirm the pipe kept vertically without any twist. If required, remove the tack and do rework. When the tack welding is completed, mark the welding guide line that is convenient for the welder for the butt and fillet joint. Place 10 mm plate on the weld joint and make weld guide line with a marking needle. Mark welding guide line for pipe joint after checking the min and max size of the welding width according to the drawing. Inspect the pressure vessel tack welding has done according to given instructions. If there are incorrect parts, remove the tacks with the grinder and do rework. Check the length of tack welds are less than 15 millimeters. Preparation for root pass welding. Right type of welding process to be used for each joint after reviewing the drawing. For the pressure vessel welding, 4 welding process to be used: FCAW, GMAW, GTAW, SMAW. According to ISO standard, dedicated number is given for each welding process. 111 is SMAW process. 135 is GMAW process. 141 is GTAW process. 136 is FCAW process. When different welding process than the specified on the drawing applied for pressure vessel joints, the joint will not be accessed. Welding could be commenced without any mistake by writing down the required welding process in advance to avoid any mistake. Butt joint welding. For root pass welding, welding sequence is very important. Generally, weld butt joint first, corner joint followed, then weld fillet joint as last. Weld butt joint with the FCAW welding process. Weld the joints with FCAW backhand technique. When root welding with the FCAW process, fill up a large amount of weldment at once. When butt joint welding with the FCAW, grind off the excessive tack welds which may turn to an obstacle because of the fast welding speed. When welding for root pass with the FCAW, the start point is important. Set the size of welds considering the amount of weldment and make uniform weldment from the start point to the end point. Finish the welding by making 2 or 3 spot welds. Remove slag by grinding and cleaning up contaminants with a cup brush. Remove spatters on weld area with a chisel and hammer. Remove splatters with a single hammering. Be careful, hammering several times may make notch indentation on the pressure vessel. This is a vertical butt joint. Weld the joint with GMAW 135 process from the bottom to top. Prior to welding, grind off the tack welds, which may create an obstacle. Root pass of pressure vessel shall withstand the hydro pressure test. The weld joint need to be filled up with weldment securely to prevent any leaks. Weave in a semicircular or in a zigzag pattern and fill up the weldment completely by pausing at each edge. For the end joint, spot welding until the weldment is deposited completely up to the corner joint. Consider it as filling the gap between two plates by welding. Corner joint welding. Weld corner joint with the SMAW 111 process. Use welding electrode KH500LF 4.0 mm. Welding current is about 135 ampere. Strike an arc at the starting point and align weld with tip of corner line, then start weaving when arc is stabilized. In general, the triangle weaving making triangle shape is mainly used. Triangle weaving is the way to move forward and backwards repeatedly, like drawing a triangle shape. Due to the limited length of welding electrode, stop-start cannot be avoided. 80 to 100 millimeter length of welds could be made with one electrode. Remove slag on the welding bead with a chipping hammer whenever one electrode consumed all. For a stop-start of SMAW process, strike an arc in front of welds, then bring it back to welds making U and connect welds when the arc has stabilized. This is the method to prevent excessive reinforcement or overlap. To complete the task, the proper time should be assigned for each stage.
자, 여기서 이거 한번 보고 들어갈게요. 제가 앞전 시간에도 이야기했지만 이 라인 제가 생명 라인이라고 그랬죠. 이 라인을 절대 용입시켜서는 안 됩니다. 이 라인이 꼭 살아 있어야 돼요.
Like I mentioned in the second session, this line, those two red lines you see are the lifelines, and you will not, please don't penetrate and go exceed those lines.
그리고 이 용접 자세가 굉장히 중요한데 잘 보시면 이 보는 눈하고 그다음 용접되는 위치하고 이 거리가 굉장히 가까워요.
And the position you see now is very important as well. You can see that the welder is looking very closely to the welding spot, to the welding area.
저는 개인적으로 용접을 잘 하려면 용접 자세가 가장 편한 자세여야 용접이 잘 된다라고 생각을 합니다.
Personally, I think that the position is most important when it comes to welding. You need to be in a comfortable position.
여기를 보면 이제 오른손으로 홀더를 잡고 용접을 하고 왼손은 받침대 역할을 해주죠.
You can see that the right hand is actually holding the holder, and the left hand is just holding onto the holder.
대부분 오른손으로 용접을 한다라고 생각하는데 그렇지 않습니다. 왼손이 고정을 잘 해줘야지 손이 흔들리지 않습니다.
Most people might believe that it is up to your right hand because the torch is on your right hand, but actually your left hand is very important because you need to support the torch properly.
그래서 이제 이 왼손, 이 손등이 가장 많이 불에 튀어요.
Actually, the back of your left hand it is the most likely area where you might be burnt.
그리고 이제 그 우리 자동맨, 용접맨하고 용접 불꽃하고 가깝기 때문에 뭐 자동맨을 쓴다거나 플라스틱 재질의 뭐 맨을 쓰면은 이게 다 녹아버려요.
And when it comes to mask, please don't use the plastic because you are very close to the welding area, and plastic mask might just melt.
그래서 우리 한국 선수들은 대부분 다 철 재질로 되어 있는 맨을 사용을 합니다.
And because of that, most of our Korean competitors use metal mask or metal protective glass, metal protective parts.
어떤 사람들은 용접 불꽃에서 좀 그 얼굴을 좀 멀리 가면 되지 않느냐라고 생각을 하시는데
Some people might think that you can just make the distance bigger between your eyes and the welding zone.
시야가 멀어지면은 용접물이 잘 보이질 않습니다.
Further you go from the welding area, you will less likely to understand the molten puddle, the shape of the molten puddle.
그래서 용접을 잘 하려면은 이 자세가 제일 중요해요.
Hence, like I mentioned, position is very important in welding.
그리고 아까 그 이 영상 보기 전에 하나 빠뜨려 먹은 게 있는데 이 압력용기를 가접을 하실 때 어떤 프로세스를 사용해도 상관이 없습니다.
And I also forgot to mention in the beginning that when you're performing the tack welds, you are able to use any process you prefer.
그런데 이제 장단점은 있어요. GTAW를 많이 사용하는데 GTAW를 하면 양손으로 가접을 해야 되기 때문에 잡아주는 손이 없어서 좀 불편하고 시간이 많이 걸려요.
But there are obviously pros and cons. For example, when most of you, I believe, will be working on GTAW. However, GTAW requires both of your hands welding, so it might take more time and it might take more effort.
그래서 우리 한국 선수는 보통 FCAW라든지 GMAW로 가접을 많이 해요.
So our Korean competitors usually do FCAW or GMAW tack welding.
아크 살리기도 편하고 그리고 한 손으로 가접을 하기 때문에 왼손으로 모재를 잡아줄 수도 있고 그래서 굉장히 편리하고 시간이 절약이 됩니다.
It is less time consuming and actually easier because you can make the vivid arc.
영상 이에 속비드 쌓는 거, 필패스 쌓는 부분 계속해서 이어서 보겠습니다.
Now let's continue watching how to address the fail pass.
To reduce working time, minimize grinding work. While weaving, reach the groove edge by no means. Do not fuse the edge of the groove because it is a guideline for cap pass. After completion of welding, remove slag on bead completely. This is horizontal corner joint welding. Weld the root pass with the SMAW 111 process. If the joint is too protruding, it is better to grind it with a grinder to remove the welding obstruction. Strike an arc at the starting point and align weld with the tip of the corner line. Then, start weaving when the arc is stabilized. Deposit the weldment up to the corner edge and progress with the triangle weaving technique. For the SMAW process, make a keyhole that is small enough to prevent burn-through in front of the weld, and progress welding. Weaving the welding rod slowly while staying on both sides of the corner, little by little. Remove slag on the welding bead when one electrode consumes all the weldment generated. Start welding with new electrode and make bead connection. For a stop-start, strike the arc in front of welds, then bring it back to welds making U and connect welds when arc has stabilized. Weave carefully in order to avoid slag inclusion or weld defects. Allow weldment to be deposited up to the edge of the corner joint, then finish welding. Edge joint welding. Weld edge joint of the vertical corner area. Weld the joint with the GMAW 135 process. Grind off the excessive tacks prior to welding. The oxide layer needs to be removed prior to welding since GMAW makes shallow penetration, and also it is a sensitive welding process. After grinding works, clean up contaminants with a cup brush. Check up to where the welding bead needs to be filled and make the weld line by weaving the torch side to side at the start point. The weave should be in a semicircle or in a zigzag pattern. The tip of the wire should pause at each edge and deposit the weldment. Maintain a 3 to 4 millimeter weaving pitch while welding. While weaving, do not let the edge of the corner get melted. The edge of the surface is a guideline for the cap pass. The most important thing is to maintain the bead line of both edges. The reason why different welding process applied for pressure vessel task is to demonstrate similar condition with the actual fabrication site. Deposit beads fully up to 1 to 2 millimeters lower than the surface. Deposit beads at the end point fully as well. It is an inclined vertical fillet joint. Weld joint with the FCAW 136 process. It is not recommended to deposit a big amount of beads with the FCAW for fillet root pass. A stable cap pass is possible when a thin root pass has been made with the FCAW because its travel speed is fast and its welding current is high. Pipe welding. Weld the joint with the SMAW 111 among 4 welding processes. Weld from 3 or 9 o'clock position to 6 or 12 o'clock position clockwise based on the front view drawing. Making round welding along with pipe curve is important for pipe welding. Keep bead height as a minimum and deposit uniformly. Weld the cover plate of pipes with the GTAW 141 process. This section is about mild steel welding. Be careful that the edges of the groove are not melting and weld along with the pipe radius while maintaining a short arc length. At this point, while keeping the angle of the filler metal to the weld line at about 10 to 20 degrees, make weld by pushing to the front towards the torch where an arc occurs. Put the nozzle on the V-groove and travel by moving the torch in a half moon or a zigzag pattern for weaving. Weld root pass of the pipe butt joint with the GTAW 141 process. Pipe to pipe connection is pipe butt joint. The weaving technique for the connection part for the cap plate and the pipe is slightly different. Welding for pipe butt joint proceeds very quickly by weaving the ceramic nozzle of the torch at the top of the groove, whereas zigzag pattern weaving applied for cap plate welding. Be careful that the groove edge of the pipe joint is not melted, and deposit welds by feeding filler metal uniformly to make even bead height. Checking the condition of welds. After completion of root pass welding, check the condition of welds. Check whether the edge of the vessel has been welded. If the edge of the weld joint melts and disappears, the cap pass welding is going to be difficult because the welding guideline is not able to be confirmed. Cross-check the actual and the drawings and confirm if the weld joint made with the welding process indicated on the drawings. If a different welding process applied against the drawing, the joint will not be accessed. Butt joint welding. Horizontal butt joint welding. Weld first cap pass with the FCAW process 136. The cap pass of horizontal welding is usually stacked 3 times in total as first, second, and third. For first cap pass, weld straightly align with the bottom groove edge. When first cap pass welding is completed, remove slag with a chipping hammer. Grind off the upper part of the first cap pass and keep the line straight. Second cap pass of the FCAW butt joint welding. For second cap pass, weld by covering 1/2 or 1/3 of first cap pass. In horizontal welding, weaving is not possible because the welding material flows down. Therefore, in order to make a sufficient bead width to the improved surface, it is necessary to stack the cap pass 3 times. When second cap pass welding is completed, remove slag with a chipping hammer. Grind off the upper part of second cap pass and keep the line straight. Third cap is the last. Cap pass, weld by covering 1/2 or 1/3 of second cap pass. In horizontal welding, the flow of the melt may be different depending on the angle of the welding rod, so pay attention to the angle of progress. When welding is completed, remove slag on beads completely. When the groove width is wider than this joint, weld joint shall be deposited with more welding passes. Vertical butt joint welding. Weld with the GMAW process 135. Remove excessive beads generated while the horizontal welding with a grinder. Vertical welding shall be started from the bottom and proceeded to the top. Check the bead width that needs to be filled at the first point of view. When the bead width is confirmed, start weaving. Weave in a semicircle or in a zigzag pattern and deposit welding beads up to the end by fusing 0.5 mm groove edge. Avoid incomplete penetration, undercut, and overlap while fusing the groove edge. Welding defect could be generated when travel speed is too fast, present contaminant, or there is a problem with equipment since the GTAW process is extremely sensitive welding process. From 5 millimeters ahead of the endpoint, keep arc length short and make 2 or 3 spot welds. Corner joint welding. Inclined vertical joint welding. Weld with number 111 SMAW process. Use 3.2 millimeter electrode and set welding current at 110 ampere. Strike an arc at the bottom part and start weaving when the arc is stabilized. For root pass, triangle weaving technique is used, but for cap pass, side-by-side weaving technique is used. Pay extra attention to prevent any defects for cap pass, which is welding profile to be accessed. Weave the arc from one groove edge to the other by keeping the short arc length. Due to the limited length of the welding electrode for SMAW, stop-starts cannot be avoided. 80 to 100 millimeter length of welds could be made with one electrode. Remove slag on the welding bead with a chipping hammer whenever one electrode all consumed. For welding stops-starts on cap pass, strike an arc 15 to 20 millimeters in front of welds. Then, bring it back to the welds and keep weaving. Keep the short arc length to prevent any welding defects. During welding, pause briefly at both ends and travel fast across the center. If the electrode paused too long in the center, it may occur the overlap. Stop welding and remove slag on the welding bead with a spot weld hammer whenever one electrode all consumed. For a stop-start of SMAW process, strike an arc in front of welds, then bring it back to welds making U and connect welds when the arc has stabilized. The bead connection of stops-starts on cap pass should be invisible. Pay attention to prevent excessive face reinforcement such as overlap. Extend welding beads to make endpoint welding invisible and to be covered by corner joint welding. Remove slag on welds with a chipping hammer. Horizontal corner joint welding. Grind off the excessive reinforcement and uneven beads. After grinding works, clean up contaminants with a cup brush. Weld horizontal corner joint with number 111 SMAW process. For first cap pass, weld straight align with groove edge. Keep 95 to 110 degree electrode working angle and weld with stringer bead without weaving by making round shape beads. When joint welding the horizontal corner, there is a part where the vertical butt welded bead meets. This part is difficult to make a straight bead, so you have to pass it a little slowly and weld it. When first cap pass welding is completed, remove slag with a chipping hammer. The horizontal corner joint welding is a second cap pass welding. Keep the welding work angle 85 to 90 degrees lower than first cap pass and weld up to the highest bead. For second cap pass, weld by covering 1/2 or 1/3 of first cap pass and up to 1 millimeter ahead from the upper groove edge. Be careful not to melt the line above the improvement surface as it becomes the baseline of the last third cap pass. For second cap pass welding, weld with stringer bead without weaving by making round-shaped beads. Grind off the excessive reinforcement and uneven beads. This is the third cap pass of horizontal corner joint. Start by gently touching the welding rod at the start point and using the arc. And when the welding material is stable, proceed slowly as soon as the welding rod melts without weaving. Weld by fusing 1 millimeter of the upper groove edge and keep uniform volume of molten metal. Keep your eyes on tip of welding electrode as the electrode would have the eccentricity while melting. Finalize it by extending beads so that an end point can be covered by the following welding. Remove slag with a spot weld hammer. For horizontal welding, welding beads shall have a profile like a knife line. Fillet welding. Inclined vertical fillet welding. Welding with number 136 FCAW process. Deposit welding beads up to the marked line by weaving. Progress welding with the weaving technique without undercut while checking 10 millimeter fillet guide line at both sides. For the FCAW fillet welding, a thin root pass made in order to keep a travel speed for cap pass slow, unlike the other passes. Slow travel speed is convenient to keep the required fillet size aligned with the marked line. After welding, remove slag with a spot weld hammer. Pipe joint welding. For pipe joint fillet welding, weld with number 111 SMAW process. Fillet size for pipe joint is 8 millimeters, and it includes all-around welding. The cap pass is piled up a total of 2 times. Weld first cap pass along with the bottom guideline. Remove slag with a spot weld hammer. This is the second cap pass of pipe joint welding. For first cap pass, the electrode work angle moves up and down, starting from the top. For second cap pass, hold the electrode work angle slightly up from the horizontal level as welding progresses as per the line above the guideline. Weld the second cap pass along with the guideline drawn on the pipe. When the size of keyhole and molten puddle is fit with marked guideline, make a stringer bead without weaving. Remove slag with a spot weld hammer. For pipe mild steel corner welding, weld with number 141 GTAW process. Weld up to groove edge by weaving. Weave and travel forward in a half moon or in a zigzag pattern. Keep the tilting angle of the filler metal to the weld line at 10 to 20 degrees. Make weld by pushing torch toward where the arc starts. When filler metal is fed uniformly, a filler metal will remain on the bead the same as this point. Pipe joint butt welding. Weld horizontal butt joints with number 141 GTAW process. Welding bead should be deposited uniformly for the horizontal butt welding. To keep uniform bead width, weaving width should be kept uniformly. Weaving along with the pipe radius by keeping uniform arc length.
자, 이제 압력용기 표면 작업까지 다 끝이 났습니다.
Now let's pause the video and you will realize that the pressure vessel is done with welding.
자, 압력용기에서 제일 중요한 것은 우리가 이제 루트 패스, 필 패스 쏠 때는 수압을 생각해야 되고요.
What's most important about welding pressure vessel is that when you're working on the fill pass, you need to remember, you need to consider the water pressure.
그리고 외관 캐패스 용접하실 때는 각장이라든지 치수, 그다음에 외관에 신경을 많이 써야 됩니다.
And when you're working on the cap pass, please make sure that you have all the materials in the correct dimension, and also the appearance matters a lot.
이 압력용기 외관에 걸려 있는 점수가 23점 정도 걸려 있어요. 그래서 이건 캐패스에서 각장이라든지 그다음에 불올, 기공 이런 결함을 다 없애야 되고 비두도 스무스하고 부드럽게 내줘야지 높은 점수를 받을 수 있습니다.
So the appearance covers 23 of all of the points, and appearance includes whether the beads have porosity or not, or if the beads are in even position.
그리고 가접이 끝난 후에 이제 우리 필패스 작업을 하는데 이 수압 시험에 15점이란 점수가 걸려 있어요. 그래서 이 속비드 쏠 때도 시점이나 이음부, 크레이터 부분을 항상 랩핑을 하고 크로스해서 용접을 하셔야 돼요.
When you're done with the tack welding and start commencing the fill pass, there's a 15-point hydro pressure test. I mean the water pressure test. You need to make sure that you have the crater welding done properly, and so there will be 15 points for the water pressure test.
보통 이 프레셔 베셔를 가접하고 필패스 싸고 캐패스 싸고 청소까지 다 하는데 걸리는 시간이 한 10시간 정도가 걸립니다. 이 10시간에 걸려 있는 점수가 수압 15점에 외관 비주얼 검사 23점 정도가 걸려 있습니다.
So after the tack welding and field pass and cap pass and cleaning, it usually takes about 10 hours. Plus there's 15 points for the water pressure test and visual inspection, which sums up to 23 points.
그래 시간적인 비중으로 따져보면 그렇게 뭐 높은 것은 아니지만 그래도 가장 많은 점수가 이 프레셔 베셜에 걸려 있다라고 할 수 있습니다.
When it comes to time and time to mark ratio, it is not the biggest, but a lot of the marks from all of the points are in the pressure vessel.
자, 이제 좀 오늘 정리를 좀 해볼게요. 우리가 지금 오늘 셋째 시간인데 첫 번째 시간에 우리가 10T 플레이트 쿠폰하고 16T 플레이트 쿠폰을 수업을 했습니다.
Let's summarize the sessions. On the first session, we covered 10T and 16T plate test coupons.
두 번째 시간에는 우리가 이제 T 필렛하고 파이프 용접에 대해서 배워봤죠.
And in the second session, we covered T fillets and pipe welding.
그리고 오늘 이제 셋째 시간인데 오늘은 프레셔 베셜의 이제 가접부터 표면 작업까지 오늘 배워봤습니다.
And on today's third session, we covered the pressure vessel, including tack welding, from the tack welding to the surface processing.
그리고 이제 마지막 넷째 시간에 해야 될 것은 알루미늄 프로젝트하고 스테인리스 프로젝트 여기에 걸려 있는 점수는 20점이 걸려 있습니다. 그래서 그건 10월 15일 금요일 날 같은 시간에 만나서 또 작업을 해보는 걸로 하겠습니다.
So the next fourth session is expected to be held on the 15th of October, and on the same time we will start covering aluminum and stainless, which covers 20 points of all of the marks.
이 자리를 빌어서 유로스킬에서 지금 열심히 지금 대회를 치르고 있는 선수들, 엑스퍼들한테 화이팅이라고 이야기하고 마무리 짓겠습니다. 화이팅!
I would like to congratulate and encourage all of the participants in the Euroskills fighting. That was the end of today's session. Thank you very much for participating, and this video will be uploaded in the YouTube.